Hello, here's part 3 of section 3.3. So a farm co-op has 6,000 acres available on which to plant corn and soybeans. The following table summarizes each crop's requirements for fertilizer and herbicide, harvesting labor hours, and the available amounts of these resources. If the co-op's profits per acre are $240 for corn and $160 for soybeans, how many acres of each should the co-op plant to maximize profit? What is the maximum profit? So the first thing I do is find the objective function. So we are trying to maximize P equals, and then we get 240 for corn, and then we get 160 for soybeans. I'm going to use B because my S's look too close to fives. And then it's going to be subject to, and then there's going to be 5 constraints. So the first constraint is not in the table. It's actually from the 600 acres. That means C plus B has to equal 6,000. Sorry, I said 600. Then from the table, we get 9C plus 3B has to equal 40,500. And then we get 3/4 C plus B has to be equal to 5250. And I kind of screwed up here. They don't have to be equal, they have to be less than or equal. And then C has to be greater than or equal to 0, and B has to be greater than or equal to 0, because you can't have a negative number of acres of corn or soybeans. So now I'm going to graph my feasible region. Sorry, got tongue-tied there for a second. So I'm going to find my boundary lines. And before we do that, again, I want to label my axes. We're actually going to have different numbers this time. We're going to go to 14,000 on the y-axis. And then we're going to go to 8,000 on the x-axis. Or the c-axis, I guess I should be calling it. So there's my axes. And now I'm going to go through and graph my boundary lines. So the first one is C plus B is equal to 6,000. By cover-up method, I get a C-intercept of 6,000. And then a B-intercept of 6,000 as well. So 6,000 and 6,000 is about right there. Okay, next we have the 9C plus 3B is equal to 40,500. If I cover up B, I need to divide by 9. So 40,500 divided by 9. I'm getting C is 4,500. So we get 4,500. 0. Then if I cover up C, I need to divide by 3. So 40,500 divided by 3. And we're getting 13,500. So then if I go through and graph that, right there, and about right there. There we go. And then the last one, we get 3/4 C plus B is equal to 5250. So if I cover up B, I need to divide by 3/4 or multiply by 4/3. So 5250 times 4/3, and we're getting 7,000 for my C-intercept. If I cover up the C, we just get that B is 5250. So we're getting 5,250 for the B-intercept. So now if I do that, it is about right here and right there. Nope, sorry. Got that wrong. And about right there. I did 7,000 on both. And now I am going to zoom in. I know you can't really do this on your paper, but let me get the orange mark up. Because now we're going to need to find the vertices. And when I zoom in here, I'm going to see that this is the blue and purple, and this is the green and purple. So notice the green and blue is like right there. So that's just going to be important when we do this. Now to find the shaded region, I'm going to just pick the 0.11. I'm not going to actually plug them in this time because I hope you realize if you plug 1, 1 into these inequalities up here, they're definitely going to be less than the thousands that we have on the right hand side. And then 1's greater than 0 and 1's greater than 0. So this is our shaded region, which means we are not going to use this orange point on the outside. So actually, let me erase it. There we go. And then here's our shaded region again. So we get a pentagon again. And that means we have 1, 2, 3, 4, 5 vertices again. I'm going to just start with the easy vertices. So this is the origin. So that's 0, 0. This is the y-intercept, or the um, b-intercept of the blue line. So that's 0, 5,250 because we already found it. And then this one is the x-intercept of the green line, which is 4,500, 0, which means we just need where do the blue and purple intersect and where do the purple and green intersect. Those will be our 2 points that we find. Actually, let me leave a little bit more room. There we go. So now I need to do some elimination. So if I go back up to my constraints, I'm going to label this A, B, C. So first I'm going to do purple and blue. Purple and blue is A and C. And I just realized if I have A and C, if I just subtract them, so A minus C, we get C minus 3/4, which is 1/4. And B minus B is 0. And 6,000 minus 5,250, that is 750. Multiply both sides by 4, we get C is equal to 3,000. If I plug that back into A now, we get 3,000 plus B is equal to 6,000. So then we get B is equal to 3,000. So then 3,000, 3,000 is that vertice. Next, I need the green and purple, which is A and B. Well, if I go B minus 3A, so 9 minus 3 is 6C, 3 minus 3 is nothing, and then 40,500 minus 3 times 6,000, we're getting 22,500. Divide that by 6, and we're getting C is 3,750. Plug that back into A, we get 3,750 plus B is 6,000. Subtract, we get B is 2,250. So we're getting 3,750 and 2,250 for our fifth point. And now we're going to plug those in. I'm not going to write out actually plugging them in. I'm just going to type in my calculator. So 240 times 0 plus 160 times 0 is 0. 240 times 0 plus 160 times 5,250 is 840,000. 240 times 4,500 plus 160 times 0 is 1,080,000. And then 240 times 3,000 plus 160 times 3,000 is 1,200,000. And then 240 times 3,750 plus 160 times 2,250 is 1,260,000. So our answer is there is a max profit of $1,260,000 when 3,750 acres of corn and 2,250 acres of soybeans are planted. And that's a good place to stop for this video. And we have one more example left in the notes.